So, have you ever wondered what happens to our cosmic neighborhood? Billions of years from now, long after the sun dies and the Earth is just gone? You'd think that's the end of the story, right? But what if I told you that new research suggests it's not an ending at all? It might just be the beginning of a spectacular second act for life in our solar system.
To really get our heads around our own distant future, we've got to look at a real-life cosmic ghost story that's happening light years away. It's a discovery that has astronomers totally rethinking what's possible after a star dies. Okay, so meet WD-1856b. This thing is a gas giant, about the size of our Jupiter, and it's orbiting a white dwarf, which is basically the tiny collapsed core of a dead star. Now here's the truly mind-bending part. Look at the scale. The planet is 7 times larger than the star it's orbiting, and it's so close, its entire year is just 1.4 Earth days long. To give you some perspective on just how wild this is, when this giant planet passes in front of its tiny star, it blocks a staggering 56% of the star's light. I mean, most planets we find barely block 1%. The signal was so huge that the automatic detection software actually threw it out at first, thinking it had to be an error. So this discovery leaves us with a massive puzzle. The whole process of a star dying is incredibly violent. It bloats up, swallows its inner planets, and then collapses. So how in the world did this gas giant get so close to its dead star without being completely ripped to shreds? Answering that question is the key to figuring out our own solar system's fate. To crack that mystery, we really need to look at the life cycle of a star, just like our sun. Because in a few billion years, it's going to go through a pretty dramatic and fiery transformation itself. Right now, our sun is in its stable, kind of middle-aged phase. But as you can see, that all changes in about 7.5 billion years. It's going to run out of fuel, swell up into a red giant, and completely swallow the inner planets. Yeah, including us. Then, after all that, it'll shed its outer layers, leaving behind just a tiny, dense core, a white dwarf. And this whole process is basically a planetary demolition derby. As astronomer Andrew Vanderberg puts it, nearby planets are just destroyed, and anything that wanders too close later on gets shredded by that intense gravity. This is exactly why finding a surviving planet like WD-1856b is just so shocking. So, here's the crucial point. The inner solar system is toast, no question about it. But as the sun changes, the conditions for life don't just vanish, they relocate. A whole new frontier of potentially habitable worlds could open up exactly where we'd least expect it. And this all comes down to a concept you've probably heard of, the habitable zone. Think of it as the Goldilocks zone. It's that perfect orbital distance from a star where it's not too hot, not too cold, but just right for liquid water to exist on a planet's surface. And we all know water is a pretty key ingredient for life as we know it. Now, here is the real game changer. That habitable zone, it isn't fixed in place. As our sun swells into a red giant, it's going to get way, way more luminous. So its habitable zone is going to migrate outwards, sweeping right past the scorched remains of Earth and Mars and head into the frigid outer reaches of our solar system. And what's waiting for it out there? Well, you've got the gas giants Jupiter and Saturn. But even more importantly, you have their dozens of icy moons. Worlds like Europa, Ganymede, and Enceladus, which are basically giant reservoirs of frozen water. For hundreds of millions of years, these frozen little worlds will suddenly find themselves basking in the warmth of the dying sun. So let's zoom in on one of the most exciting candidates for the solar system's second act, Jupiter's moon, Europa. Today, it's a ball of ice with a massive ocean underneath. But in the red giant phase, its surface is going to go through a truly epic transformation. This heat map from a new study shows us exactly what happens when Europa drifts into the red giant's habitable zone. The new heat doesn't just melt the surface ice, it kicks off a really cool process called sublimation. Sublimation is the absolute key here. Because Europa has such low atmospheric pressure, the surface ice will actually skip the liquid phase entirely and turn directly into water vapor. And this process will be powerful enough to create a brand new, albeit thin, atmosphere all around the moon. And here's the most incredible finding of all. The models showed that this new water vapor atmosphere could actually be stable for at least 200 million years. I mean, that's a vast amount of time. It's certainly long enough for a once frozen world to have a temperate climate, and maybe, just maybe, for something amazing to begin.
Okay, so if this is a real possibility, not just for our solar system, but for countless others out there, how could we ever spot it? How could we find evidence of life getting a second chance on some moon orbiting a distant, dying star?
Well, the scientists behind the Europa study came up with three fascinating ways we might just be able to detect these thought out exomoons. First, we could find a moon that got kind of kicked away from its parent planet and is now orbiting the white dwarf all by itself. Second, we could get really lucky and see the moon itself pass in front of that tiny white dwarf. And third, and this is super clever, we could see the moon pass in front of the light that's being reflected off its giant host planet. Now look, these are really complex signals to find, for sure. But advanced telescopes like the James Webb are making these kinds of incredible detections actually possible. Whether it's seeing a moon transit its star, or even using a planet as a giant mirror to spot its moon's shadow, we're officially moving from the realm of science fiction to real, testable possibility.
So, this all brings us right back to where we started. Far from being just a final, destructive end, the death of a star could actually trigger a great thaw, transforming frozen, icy moons into temperate water worlds. It really suggests that the final chapters of a solar system story might just be the most interesting ones, offering a second chance for life to emerge long after its original homeworld is nothing but a memory.